All right, guys, today we're going to be doing some maintenance on this 6.5-liter diesel engine on this 99 Suburban. And what we're going to be doing is a glow plug replacement starting on the left-hand side. And just to let you see the factory suggested way of doing this here and the torque values for reinstalling them, the left side or the driver's side is pretty easy and straightforward. Now, besides just removing these, I'm going to go over how you test them as well as how you test the harness connections. And I'm also going to cover how you can fix the connectors at the end of the harness connectors, at the end of the harness itself if they're damaged. So let's go ahead and get started. All right, guys, since we're going to have the hood up for a while, we're just going to want to disconnect it here so we don't drain the battery. All right, guys, let's go ahead and get started here. What I'm going to do is the first test, I'm going to do the same test on each glow plug. So we're on the driver's side. So we're on the 1, 3, 5, and 7 cylinders here. The first test is to test the connector and make sure that we don't have a problem with the end terminal, right? So these first two are probably the easiest to get into view. I'm going to just grab the wire in the back here, and we're just going to give it a gentle tug on this number 3 cylinder and a gentle tug on this number 1 cylinder. And so what we're trying to do is we're trying to make sure that the connectors are holding on really tight. Now you can see the type of connector here, it's like a white connector with a little ridge on the back. This is a ceramic type of connector on this 99 Suburban. If you back out the camera just a second here, I'll show you a different type you may encounter. This is a type that I took off of a 99 K3500 chassis cab. So same year, same Chevrolet, different, 1-ton type truck. And it's the same fusible link inside here, but now it's more of a plastic type connector. It's narrower and it's kind of a grayish, maybe brownish color. I don't know if you guys can make that out. So you might encounter these. I've seen these in express vans as well. So 2 types of covers that go on top of the terminal. After we get done with this, I'll show you how you take apart this type of setup, either of those, and how you can test and repair the actual metal terminal that's inside this housing if you've got a problem where it fails this tug test. All right, so going back down where we were, the next test we're going to do is we're going to go ahead and I guess we'll do this number 3 one because we have the easiest view with the camera. And we're just going to go ahead and pull this off. So you want to grasp the actual housing of the connector and pull it off. You don't want to pull it off by the wire. And so here is another example. Let me get that other one I had here for a second, show you. If I get them side by side, you can see these are 2 different types. But both of these are Chevrolets, model year 1999, old body style with 6.5-liter turbo diesel VIN code F. 2 different types of connectors that you can run into. Either way, same approach to the tests we're doing here. So this next test that we're going to do, we're going to go test how well our whole wiring system is performing. All right, guys, so for this first test, we're going to be testing the wiring harness. So if we back out a bit, what I'm going to be doing to test the wiring harness is I'm just going to be using a test light. And we're going to hook the test light up to the negative terminal of this battery that we've got right here. And the positive terminal, we're going to reach down and grab, one at a time, we're going to grab our glow plug connector. And we're going to get it inserted in here and hold it in position. And we're going to have to turn our flashlight off just so you guys can see. And what I'm going to do is I'm going to set the camera up so you can see this light up when we turn the key and put it in the glow plug cycle. All right, guys, now I'm going to go turn the key here. And if our harness is good, there you go, we see it lit up. And then we're going to turn it off so we don't heat these other plugs up too much, make it more difficult to remove. All right, so let's move on to the next test. All right, guys, so let's go ahead and pull this plug. I'm going to go ahead and take this connector and get it out of the way so it doesn't get damaged. I'm going to put a 10-millimeter long socket on here. These things should not be that tight. They shouldn't be, but there he goes. All right. All right, so he's loosened up. Get him the rest of the way. Turn him by hand with the socket. It's probably the best approach. And so when we get him out, we're going to do a resistance test on this plug. It's very similar to pulling a spark plug. Not exactly the same, but some long threads to it though. It'd be nice if you can get an electric ratchet in here, but there's really not a lot of room because of the steering shaft. All right, there we got this guy out. And we can see that the tip is intact. All right, so the test that we would do, like what if we wanted to reuse this guy for some reason? And so the test we would do on that is to grab our voltmeter. Let's do this test on the resistance of this glow plug. So we're going to put our voltmeter to measure ohms. And we're going to put the positive terminal on the spade that the wiring harness connects to. And then we're just going to touch this to a non-corroded part of the base that screws into the engine block, and we're going to see what we read. In this case, we're getting 0.8, 0.9 of an ohm. Now, if we compare that to the brand new one that we're going to replace it with, going to be replacing it with one of these 60G ACDelco plugs. And we measure that same test on the brand new one. What we get on this guy is 0.9, 0.8. You know, it fluctuates because your hand might be moving a little bit. So we're going to go with 0.9 or 0.8. So what's a good pass for this type of a test? Well, a good pass for this kind of a test is anything north of 0.5 ohms and anything south of 2.0 ohms. Anything in that range is probably okay, though I would throw out personally anything that was one notch below. So I'd throw out something that was 0.6 and I'd throw out something that was 1.9. This one's okay in terms of resistance test. Now, if we zoom in and look at the plug itself, this is not a test per se, but another thing we want to inspect is corrosion. Right? So what we're looking for on corrosion is we don't want any corrosion interfering with a connection from the wiring harness to the spade. And we also want to take a look at this little spot welded piece down here because we want to make sure that this is not getting corroded where it's getting ready to come off or interfere with the connection. Now, similarly, we want to make sure that we don't see any pitting or excessive corrosion where it screws into the block. You can see she's super shiny where she was embedded in the cylinder head. And then the actual threads have got a little bit of surface corrosion. But again, there's nothing on here that you would condemn the plug over. And similarly, on the heating element, we're just looking to see if we see any cracks or we see any parts that might indicate that this guy has swollen, and we don't see anything that would condemn it that way. So technically, you could reuse this particular glow plug. There's another kind of test similar to the one that we're going to do with the test light to test the wiring harness, where instead of running the test light from the negative terminal of the car battery and making contact with the wiring harness when you turn the key on and get the glow plug cycle going, you could connect it to the positive terminal of the battery and you could touch it to the spade of the glow plug while it's still in the block. That'll be another kind of conductive test, but the test I just showed you, I recommend over that because it's more accurate, because what we can find is with that test with the test lamp, you might get it to light up when this is outside the resistance range. So you would want to take it out to find out if that's a real reason to discard it. Okay, so now let's keep going. How often do you change these things? Well, GM doesn't say. They don't give you a specific change interval, but they do give you some guidance. Let me share some guidance that they do give you. All right, so we got a box of 8 of these. And it's GM part number 12563. 554, and again, it's a 60G. The reason we're using a 60G is there was a service bulletin that came out back in 1999 that said that there was a new design plug, which is the part number I just gave you, that is going to be used in all 6.5-liter engines nationwide. The new plug, it's got some kind of etching on it, blah, 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 but it replaces the 11G model used previously, and this is what's used to service all prior 82 to 93 6.2s and 92 to 2000 6.5. So this plug was redesigned to make it, in this one respect, less likely for these tips to swell up and get stuck in the cylinder head, for example. So much needed improvement there. I'm sure there were some other improvements as well in terms of the heating time, but we're going to put the 60 Gs in there because that's what was in there. As we can see, I think we could see from the old one. I don't know if they etched that in here or not. It's kind of hard to see. I do see ACDelco. Can't really make out anything else though, but I'm sure these are 60 Gs. And we'll replace them with those using the torque value we saw earlier. So those are the two tests. Now we know that for each of these, we'll repeat that test on 1, 3, 5, and 7. We'll know that the harness is good back to the relay, and we'll be able to tell if we wanted to reuse the plug. You can also get a situation where there's no ohms at all, where it has failed in some sort of open state, and you can get a situation where the ohms are really off, way higher than 1, 5, 10, even higher, in which case the plug is also bad. Now, what if you had a problem with the terminal not staying on, if it failed our little tug test? Well, I'm going to go back in the workbench and I'm going to show you how to fix that problem. But for now, I'm just going to repeat these tests I showed you on all 4 of these cylinders on the driver's side, pull these out and replace them and torque in the new ones. Okay, guys, let's talk terminals and connectors. So the type of wiring harness end that's used on these glow plugs on these 6.5 liter diesels is a GM Packard Electric Series 56. Became Delphi and now it's Aptiv, but these parts are still available. It's a connector block secured on top of a crimped on terminal with the wire. And there's a special tool that you can get to separate these. I'll put a link in the description, right? That's currently sold under the Aptiv name. And the end of this tool is designed to fit in this squared off area on the top of the connector block. And you don't want to prise with it. It's not like a screwdriver or anything like that. What you're trying to do is slide it in and depress the tab that's on there. And there's usually some play in the terminal, and so it can help to kind of push it forward. And then take this guy. You can kind of feel when you've got the terminal. It's right in the center area there. And then once it goes in all the way, you typically have got it depressed. You can remove the tool, and the terminal and the wire will come out. And all this guy's doing is there's a little retaining tab right here. Take this little flathead screwdriver, we can kind of move it back upright. And that little tab is what secures it on the block. Right? So the blocks, if they're not damaged, they're completely reusable. There's a ridge inside that this catches on, and if this guy's not cracked or disintegrating or falling apart, it's perfectly reusable. This particular connector, if you can see on the end, or this terminal, you can see on the end, this is a little bit different than an F terminal or a fast-on type terminal, right? We can see here that we've got this tongue in the middle that's got some spring to it, as well as the 2 side pieces that retain onto the male piece of the glow plug. So it's a lot more surface area to make contact with, and it can carry sufficient current for the glow plug application. If you need to replace these are also still available from Aptiv. So looks like this. I'll put a part number below, but I have located the exact replacement. Whoops, not right in the camera view there, right? There's an exact replacement for these Series 56 type female terminals. And most of them are going to be this kind of plated finish, but the number 4 and the number 6, at least on most of the ones I've seen, use a brass version of the same thing. So this is normally part of that assembly that we'll see when we do the passenger side that can be replaced as a unit. And these just get crimped. This piece here crimps the insulation, and this piece here will crimp the conductor. Now the actual blocks, the brown type here and the white ceramic type, long ago discontinued. But there is a replacement for the brown one that's still available. It's in gray. It's obviously the identical kind of thing. There's just a little bit of a surface difference right here with this kind of ridge at the top cosmetically. But if we look at the data sheet from Delphi here, We see what this Series 56 looks like. This particular one that I'm looking at here in the gray color, it's made of a material called PA66. There's also a cream colored one, the same thing. The other ones are made of polypropylene. They won't be able to hold up to the heat. But this PA66 type plastic is rated pretty high. I'll roll something at the bottom. I'm forgetting off the top of my head what it's rated for, but it should be sufficient. If not, you'll see a lot of aftermarket ones probably using this exact same part or a knockoff of it with a little fiberglass sheeting over the top to protect it. You can get a ceramic one, and I mean a real piece of ceramic. And what you can do is, I put a link to the description also, on eBay and Amazon, you can get these Asian vehicles have their halogen headlights use something like this. And you can get these pretty cheap, and you can open it up. You just peel the shrink wrap that they put on the outside of these. And then we can use our same tool to extract these. These are going to have a fast-on type connector, but we can still use our same tool to depress the retainer on these as well. You can see there's the difference between a Series 56 and an F2 type fast-on connector, right? Very different design, very different application. But these pop on just the same way. Let me give us a little bit of a pull up here, and you can just take them on and they snap on just the same way, right? And they're pure ceramic, so it's a perfect application for these glow plugs. So if you're trying to keep it somewhat similar, or you want to have it because GM was using a ceramic type, there's at least something like this that might be an option for you. So what if we need to change one of these out? Well, let's look at doing that next. All right, so this guy here, let's take a look at this guy here. So he's pretty corroded. Let's go ahead and replace him. So we'll just cut him off as close to the fusible length as we can. And then we're just going to pull enough of the insulation off, about 1/8 or so. And what we're after here is when we put it against the new Series 56 terminal, what we want is to see something like this. You want to see a small gap where it's going to crimp onto the conductor, and then have the conductor just peek out past the crimp just a hair. So it should be cut just like that. I'm just going to take one of these MSD type tools. There are a lot of different tools that you can use for this. And I'm just going to lay our terminal on here and just get it kind of started so that it'll hold the terminal in place. And basically what a tool like this does is, you can see hopefully with this white background, if I zoom in a little bit, there's some cuts on the top of the die that are designed to fold these metal pieces of the terminal into a nice fold. Well, you know, I released my grip there, but you get the point. It's designed to make it fold just like you would see in the factory version of this crimp that we cut off. You'll see a nice fold of the metal. So if we just hold our tool in position with this, and then we put our wire in the way we were discussing earlier, so we can look on the other side and we can see how far it's protruding in, and then we just give it a crimp. And voila, we're done. Now this fusible link is kind of large, so it doesn't get us as ideally of the kind of crimp I'd like to see on the back end, but it's certainly good enough for what we're doing here. And then we've got our crimp very nice on the actual conductor. And then we can just slap a new connector block on if that's what we need to do. And we're ready to put this guy back on, and he's all ready to go. All right, guys, you'll be able to do the plugs on cylinders 1, 3, and 5 from above under the hood. But number 7 is easier to come into this position underneath that you see me on here. With these diesel trucks, you don't really need to jack it up. I'm just under this vehicle with it in its normal suspension height, and that way you can remove and then torque the number 7, and this is also a good position to torque the number 5. As you can see, what I'm using here is a 1/4 inch torque wrench, and then I'm using an adapter to a 3/8 10 millimeter deep socket. That sort of combination worked out well for me. We're done with this side. We're just going to hook up the dangling connector. Everything passed in terms of the harness connectors, and everything passed in terms of all 4 of these are showing us a good test light. So we're going to go move on to the passenger side now. We've wrapped up that driver's side, and we've done the 13 foot-pounds or 17 newton meters, whatever your torque wrench requires. On the left side, remember driver's side is left side. Now we're moving to the right side, or the passenger side. And so for this, as you can see in the diagram, there's a couple of heat shields that we're going to need to remove in order to get the number 2 and the number 4, excuse me, the number 4 and the number 6 cylinders out. And then on the opposite ends, we'll have the number 2 and the number 8 will be the one all the way in the back. And the way the service manual goes over this, take off the right front tire, remove the splash shield, and then you get the access you need to do the 2, 4, and 6 cylinders, and remove the heat shroud, blah, blah, blah. And they talk about reaching underneath to get to cylinder 8. And cylinder 8 is easiest to see from underneath the vehicle, but let's go ahead and knock 2, 4, and 6 out next, and then we'll go over what we might have to do on number 8. All right, guys, we've already gotten the clips off of the 2 sides of our shield. You can tell I keep these replaced when they go out. I put new ones in. I'll put links in the description for those shields, and if you end up breaking one of these little Christmas tree connectors, it's a 332, 364 type of plastic retainer. And I'll put the link to this in the description as well. So we're just going to get this last one off with the trim removal tool. Right, so the whole thing comes off, and you can inspect these guys to see if any of them are shot really bad. They should be very much like this one. These are all pretty good. This one, you know, he's a maybe. We might replace him later, but let's go ahead and get into here with what we're after, which are these glow plug wires. Let's see if we can get some better light here. All right, so a lot of corrosion here. And then what you got here is the heat shield for the number 4 cylinder. And here's the heat shield for the number 6 cylinder. Then up here in the front, let's get this guy to let go for a second. Up here in the front is our number 2 right up there. So he's the easiest one to see. Obviously, we'll start with him first. Now you'll notice that we don't have the blue colored fusible link like we had on the driver's side. On this side, we have an orange Teflon covered type of wire because of the increased heat. So let me see if I can find the best spot. And I also already dropped down my test light for testing the harnesses. We're just going to pull him the rest of the way down. He's hooked up to the negative battery terminal, just like we did on the driver's side. So start off with number 2 here. This engine's a little warm. I'm going to find out how warm it is. All right, so we're going to do our tug test. I'm going to have to block your view for a moment, guys. But you can kind of hopefully see me right above this air conditioning cable, our hose. I'm just doing our little tug test to make sure she doesn't come out too easily. And then I'm going to go ahead and remove it all the way by grasping the actual connector, wiggling it off the glow plug. All right, so there's our number 2. And you can see here our number 2 plug on this factory harness, like we were showing on the other side, is not a ceramic kind of connector. It's one of those other types of connectors that I was mentioning, the plastic kind. And then if I can pull this heat shield insulation off, you can see that orange wire in there, hopefully. All right, so there's number 2. And it's very easy to get in here and get number 2. Now to get number 4 and 6, we're going to have to remove these 2 heat shields held in place by these 2 nuts. They look like they're 15s. Now anything that's exhaust manifold related, my take is you want to heat those things up before you try to pull them. Just too much of a chance of the stud breaking or something like that. We'll give it a small try before we do that, just to see if we can avoid that. But if it's give us any resistance at all, we're going to heat that up first. Let me go get a socket and we'll get started on those two. All right, guys, you can see I've zip tied the harnesses for the number 4 and 6 cylinders up and out of the way, because we are going to have to heat these nuts up to get them off, just so that we don't break anything, because they've been here for so long. Now, I'm not going to use a torch for around here. I'm just going to use one of these inductive heating devices. So we're just going to use this guy here. We're going to take this guy and heat him up. This way we don't have to worry about damaging any of these lines. And you don't have to get this guy cherry red or anything like that. Just till he starts to discolor, should be enough. You start to smell something. If not, we'll give him another bang. The main thing we want to do is we want to make sure that we don't break anything. Take a simple maintenance job and turn it into a whole day repair. Just trying to crack the rust between the nut and the threaded stud. Okay, see a little bit of smoke coming off of there. There we go. Makes quick work of these kind of problems. Now, if there was some more resistance, I'd do a little thing where you go a couple back, 4 out, 2 back, right? Something like this where it's just coming off nice and easy. We'll just bring it right to the end and let it cool like the one you see next to it. So I'm going to go ahead and remove the other two, the one here and the one here, and we'll pull those shields out and we'll get started replacing 2, 4, and 6. All right, guys, now that we've got those 4 bolts off, I'm a real big believer in heating up anything exhaust related to avoid having drama and a hassle like that. In the old days, I would just grab MAP gas, but these induction heaters are a lot faster and a lot less damage to wires or stuff that you might end up hitting. All right, so we took both the nuts off here, number 4. And basically, I just want to show you there's a little bit of a different setup on number 4 than we saw on the other side and that we see with number 2 and number 8. So you can see there's a connection here where the wiring harness, where it's orange, comes into. And then this guy goes in through this heat shield. And then hopefully if we tilt the camera down here, you guys can see there's our glow plug, right? So we can do our tug test. I'm going to block your view for probably a second here just to do our tug test. And then we can probably, I have to get the flashlight out of the way, reach my fingers in here, maybe. Can't remember if I can fit my fingers in here. Nope, I'm going to have to get a little pair of long-nose pliers to unplug this guy. So let me grab that real quick. But while I'm doing that, I can tell you about what you would do to replace this. So the GM engineers kind of thought there would be a problem with this. And so they came up with this piece here with this part number you see, 153-20904. And it's just a complete assembly from the terminal cover on down to that pigtail connector that you can swap out. And there's also an ACDelco replacement plug for the end that goes on the wiring harness as well. I'll run these part numbers down in the description in case you need them. But what we're going to do is we're just going to reach up here very gently with these long nose pliers and work our terminal off. And again, stressing very gently. The fact that it's on here really good is a positive thing. I don't want to give it too hard of a grip. Damage it. There it is. All right. And we can see once again, this is that plastic kind of connector that after we were doing the driver's side, I took you through that clip on the bench where we disassembled these. you can see that that's that plastic kind of connector. Now, actually, when we looked at the replacement one, if I go grab it again, we can see that that one includes the ceramic type connector. So I kind of feel like GM was in the process of phasing over to these ceramic connectors. Didn't quite complete that. Right? And so then we could take this guy off. If for some reason he was really, really bad and needed to be replaced. And I'll put part numbers for these shields in the description as well if you need to replace them. But that is how you get access to number 2 and number 4. And then we're going to pull the nuts off here, and we'll have the same kind of access to number 6, although this downpipe is going to really be in our way here. So let me get these kind of off and show you how we get into number 6. All right, guys, once you get the 2 nuts off of this number 6 one, just kind of wiggle him out. And it looks like you're not going to have the clearance, but you do, right? So he'll just come right out like that. Set him over here. Now we can have access to do our tug test. We can see is fine. And actually, I have even better access to this terminal than I did on the other one. Still can't get 2 fingers around it though, so I'm still going to have to resort to pliers. Again, I'm just trying to make sure that I very gentle, because this stuff has been subjected to a lot of heat. And now we've got number 6 out. All right, so now we can go ahead and remove the 6, the 4, and the 2 glow plug. And we'll go ahead and pull those out, and I'll set them down here, and we'll do a quick ohm test on them, and then we'll go put the new ones in. All right, guys, and we're getting number 6 out. I'm just showing you here, you know, you can get a 10mm deep socket, a wobble, a long extension. As long as you use 1/4" hardware rather than 3/8, everything fits nicely. All right, guys, so you should be able to stick your hand right down through here all the way to the bottom, because this here is the number 8 glow plug line. You see it's that orange Teflon covered type of material. Now we can also see the wire looms on this are all cracked from age. They need to be replaced. That's something else we'll be doing after we get these plugs swapped out. But I'll show you a view from underneath coming down and touching the connector of that glow plug. I don't know if we'll be able to get it out because looks like there's an old oil leak down there. Might make it too slippery, but we'll give it a shot. Over here is the wire loom I'm talking about. I'll put a link in the description for this size. But what we'll do is we'll replace any of this that's cracked or corroded or missing to provide the original protection that was intended. All right, guys, to number 8, in order to get the connection off, I'm going to come in through the top like we showed, because you do have access that way. You see, I got my finger right on the plug, so I can do my tug test. And I see that's okay. And I can get this guy to hopefully come off. Super cramped, and I'm hoping I can do it from here. Otherwise, I'll have to do it from underneath when I do the rest of it. Definitely don't want to pull it by the wire, so if you can't get it from the connector, you're not going to be able to do it from here. So it's very greasy. I guess there's a little bit of an old oil leak or something up here. It's making it super slippery, and I can't get a grip on it. But that's it. That's where it is, so you guys can see him. We're going to end up having to pull him from underneath because you really don't have any access. If we zoom out, right, you don't have any access here. Some people like to drill a hole right over here so you can shoot the socket straight in through the wheel liner here. Some people like to take the wheel liner off. I'm fine with coming up from underneath. Sometimes, you can get a hold of it from the top, but in this case, with that oil all over it, there's no way I'll get a good grip on it. So let's just go ahead and put the rest of this back together. Of course, with everything disconnected, we'll do our test with our test light to make sure our harnesses are good, the same as we showed on the driver's side before we connect them all back up. It's a good idea to, mark every other one of these, like number 4, number 6, number 2. You don't have to put on every one just so you don't get them mixed up. and we'll come back when we go do number 8 here. All right, guys, we got everything put back, plugged in on 2, 4, and 6. We've got our heat shields back in. The only thing I'm going to use anti-seize on is right around the neck of these nuts, and you can see I'm putting just a very light coat, and it's just to help prevent us having any kind of corrosion if we ever have to do this again. You can see these nuts are not in too bad a shape. Get them over here in the light, right? We can see still plating on the bottom flange of this nut, and of course the threads look great. Now if we kind of zoom in a little bit, right, they're in good shape here. So I'm just trying to make sure that it stays that way. Most of the corrosion is happening on the outer portion of the nut, so we're in pretty good shape there. So we're going to get these guys back on. I'm going to show you real quick in the manual the torque value for these. And then we're going to put our wheel back on, and we're going to lower it down and knock out number 8. We already did our test with our test lamp to make sure our wiring harnesses were good, and we already inspected our terminals. So we're down on this installation procedure, right? So the same torque value we talked about earlier with the glow plugs, and like I said, we already did 2, 4, and 6. The heat shields get 23 Newton meters or 17 foot-pounds for those 4 nuts as far as torque. And again, I just used that very light bit of anti-seize to prevent the neck of the nut where it touches the stud and the heat shield from getting corroded into position, just to make it a little easier next time. I would not put anything on the threads because that'll mess up the torque value and you'll end up over torquing it and make it a lot harder when you get done. I'm also going to go through, before I button all this up under here, I'm going to go through and replace all of the missing wire loom. You can see I shouldn't be seeing all this bare orange wire. I'm going to replace the rotted off wire loom like we saw above in the upper hood area. Then we're going to button this guy up and do number 8. All right, guys, we're back underneath the truck, got the wheel back on, and you can see there's not a lot of room in here at all, especially the Suburban being 4-wheel drive, having rear heat, rear AC. But if we zoom in here, we can just see our connector right there. And so, yeah, we'll be able to get in here with the long nose pliers, and we'll be able to move this ground strap out of the way, and we'll be able to unplug him. But we really don't have a whole lot of room to get anything in here. You know, maybe a 1/4-inch type of ratchet. So we're going to go ahead and unplug it from here and then fish it out above so that we can clean it up from this. You can see the oil on here right there, right? We're going to fish this guy out so we can clean him up and repair the wire loom. And then I'll show you how we can come in from under the hood. And what we can do is we can use this like an access window to help us line up the socket going onto the plug, both removing it and installing it. All right, guys, we're back on top, and we're going to reach down just like we showed last time. And I'm only being careful with this because all these looms are, falling apart. I'm going to try and get them out without them all falling all over the bottom here. You can see our guy's got a lot of oil all over him. Try to clean this off. So we can see this one here in the back is another one of these ceramic type connectors. And you can see it's just crumbling in my hands here, this old electrical tape from the heat. We're just going to try to see if we can clean all that gook out with some. It should just be dried up oil, so it should clean up pretty well. Yep, all right, so I'm going to spend some time to clean this up. I think we can get it cleaned up without disassembling it. You can see here we do not have any corrosion on the connector. I don't know if you guys can make it out, but it's just been somewhat protected by this leak. We're just going to have to figure out how we get all that gook out of there. So clean this guy up. All right, so now we've gotten our wire out here where we can replace the broken loom. You guys can see maybe here, this pull up here, stuff's just crumbling in my hands, this wire loom. So we'll place the part of the wire loom that's broke back down in this direction. Maybe if I come back over here, you can see there's a hole 6-inch or so piece of the Teflon wiring that's exposed. We'll replace and patch that in. We'll get this terminal cleaned up, and then we'll go ahead and test it with our test clip over to the negative battery terminal, and that will complete all 8 wiring harness checks. And now we need to get that last plug out. So we saw that we don't have the clearance that we would like down below. So what we're going to end up doing to come in is we're going to come in from over here. And again, you know, the objective I have here is to do the minimal amount of disassembly on these old trucks, because the more you take apart, the more likely something's going to break from age and corrosion. So we're not going to try to yank the fender off or the inner fender well, right? We're following the service manual procedure. The problem with the service manual procedure is I don't think they envisioned the Suburban. It's just too packed. So we're going to take out this air box. Got a strap here, and then when we open the clips inside, now this is a 99, so I think the 96 and up are going to have this design, which is a kind of a round one. Older ones will have a different flat style. But we've got a couple of little rubber guys that are holding this on, as well as a bolt that's coming up from underneath. I'll go see what kind of size that is, but we're going to take this out so that we can pull the 2 bolts holding this coolant reservoir. And I'll show this in a minute. We're just going to move this guy over here so that we can come in over here with the ratchet wrench. All right, we've got the wire loom repaired, guys, back here. I'm just going to put a piece of tape right there at the end, you can see, but just got that in a minute. And then we're going to go ahead and test that our circuit's okay. Turn the light out so you can see it. We got a helper inside on the dash. It's going to turn the key on. You see it lights up, we turn it off. Now if we left it on, it would cycle through. You know, you don't need to do that. We just want to verify that, just like the other 7, that this 8th one is fine, so that we know we don't have any problems from the wiring back to the glow plug controller or relay. So let's go ahead and start taking this apart. These pieces here are not part of the mounts. In fact, I'm going to have to replace this busted bushing now that I'm in here seeing that. It's actually this 13mm bolt that we can find underneath. If we come underneath here, this guy right here, there's a 13. He is in there. Well, I'm going to have to get a better leverage here, guys, but this is the one we need to take off. All right, guys, I'm just getting the last of the 2 13s that are holding our coolant tank on. We took off that 13 that was holding the air box on. I'll show you how that comes off here in just a second here. Finish getting this guy out. Neither one of these have been removed for 22, 23 years or so, whatever it is. All right, so the way this guy, remember we said we have to take off and loosen the tension on this band. That'll let you remove this piece, which just sits inside the box. And then the box, we took off the 1 bolt that's holding it down here, but then we just have to work this piece that snaps into the fender area. You just have to work that out without breaking it. A lot of patience, go nice and slow. So you can see those 2 rubber bushings are just attached to this bracket. It's got a tab and a bolt. The tab goes here and the bolt goes there. So now we've got this guy out as well. Thought I heard something moving around in here. Oh, it's just this thing moving, I guess. All right. All right, so now we should be able to move this guy. So we're going to pull this hose out of these brackets. There's 3 of them on this Suburban. Other models may be different. And then I'm going to have to get a small flathead screwdriver, because what we're going to want to do is release this retainer here on this hose so that we can lift this guy over and move him back. We'll probably have to pull this low coolant sensor harness off. Get a little tool in there. Can't quite get my finger in there to release the tab. And then we'll have plenty of room to move this guy over here. All right, guys, I got a little camera down here to show you us pulling this number 8 plug out. You can see she's coming out just fine. Actually, looking at the camera, I let the socket shift a little bit. Unfortunately. All right, so this is a real awkward setup. I'm going to have to show you what I got going on here, though. So what we've got is we just come in here, and you probably can get this with less extensions than I did here if you have some, but 1/4 inch hardware all the way up until here just because I couldn't find my longer extension. And we're coming right between the AC line and under the coolant line. Since the coolant line's rubber, it lets us pry up and get some flexibility on that. And then we've got some blue tape around our swivel so it doesn't flop around so much. Now, as I remove this, I'll pop in underneath and I'll show you the view from underneath. So you've seen the view on top with the camera that we've got focused in there, and then we can show a view underneath. But let me see if I can get this socket back on from up here. What I've usually found is I have to go underneath to get it lined up properly. Probably will have to do that again because it's such a tight fit. There we go. Maybe not. And then sometimes the swivel gets bound up. But you can get it off like this. There she goes. All right, so we're just going to work her off, and let me go underneath and show you what the setup looks like underneath. All right, guys, back underneath. So here you can see the socket on the glow plug, and you can see that blue painter's tape I mentioned around the swivel to keep it a little bit stiff so it doesn't slide off. Obviously, I can't finish pulling it out with holding the camera here, but we're going to get our long nose pliers just like we used to pull the plug off, and we're going to work this guy off while you have a helper slowly pull back on the extension. All right, guys, we're going to work this socket and extension piece back a little bit, and we'll leave the view of the bore camera. I'm just going to take the pliers here and try to help move our socket back out of the way. Okay, we got our socket off. We're going to sit it right there. Hopefully, we got this guy all the way unplugged, which we do. I can feel him letting go. And then you got to make sure you got some safety glasses on in case you drop this, but you just pull him out with the pliers. And that's it. All right, guys, so what probably saved us on this one in the back was the oil leak that it was incurring, because that prevented any corrosion. As you can see, as I get the oil off of here, that was a nice preservative for this situation. And this plug, as you can see, was starting to swell. If we zoom in on that tip, you can see a bulge right here. And so we kind of lucked out from that regard as well. So we got this guy off. Let's go ahead and test him. He's our last one. And what do we got on this guy? Oh, well, he's a bad one. This is good. You know, here we go. We got 7 that were okay, and then number 8 here is about 14 ohms. So this guy is definitely shot. So both internally, the higher resistance and the beginning of the swelling. This is why you change these on, you check these rather on a regular basis. So what do you change them on? You know, what's the criteria? It's not like a spark plug that you change out every 100,000 miles. But you want to check them at least every 100,000 miles. And if any of them fail an ohms test like this, then you change all 8. You never just change one at a time. That's my advice. Change all 8 so that all 8 are of a known quantity and you know that they all came out of the same batch. If any of them have rust along the spade like we were talking about earlier, then you change all 8 of them. Because if one's rusting in that batch, then the others are likely going to have the same kind of plating weakness as well. Same thing with rusting along here. What usually happens is this gets so big and swollen that you can't extract it. There is a tool you can use to pull it out if it got worse than this one. I'll link that in the description. But what also can happen is you can get corrosion right here around the neck. right? This little weak part between the hex head and the beginning of the threads. And you can have a situation when you try to take it off, it just snaps off right here and you end up with this whole thing left in the block. That's a really bad day because there isn't a good tool for that. That's definitely a pull the head kind of repair or just leave it be. So we're going to put the new one in. We're going to fish him in the same way that we took this one out. We're going to put the new one into that socket that we already have in there. We're going to take our long nose pliers and we're just going to gently guide the electrode into the hole, push it in, and then we'll torque it from up on top, and then we'll show buttoning everything up. All right, guys, we're underneath here guiding our new plug into the hole. Just got the camera person hopefully filming from above. And just got to get it lined up here. We got a little mirror to help guide us into the hole. And just twist it in by hand, and then we'll put our socket back on it, and we'll torque it down to spec. All right, guys, again, just showing you on the bore camera as we tighten this guy in. Just threading him in. As soon as we get him threaded in hand tight, you can see the deal I've got up here is I'm just using this handle piece on a 1/4-inch drive just to do everything hand tight because we don't want to over tighten anything. And then when we get it high hand tightened, then we'll go ahead and torque it. All right, guys, torque value on the bolt that holds our air filter box is 25 Newton meters. And yes, I'm going to change that, but we're gonna wait and do that when it's fully ready. This guy back here, we're going to do 10 Newton meters or 89 inch-pounds. Go lower on that than you normally would because this aged plastic can break and crack. This little guy here, we're going to do 5 Newton meters. And actually, I'm not even going to take him too far again because things can crack. So I'm just going to go and he feels kind of snug. And we are done torquing everything down here. The last thing I'm going to show you before we wrap up, right, we've got our 8 glows that we took off here. And just going to kind of show you, right, so we had our one bad one on cylinder 8 figures, right, the very last one. But even if we look at these, even though all of these passed the ohm test, and even though all of these, you could argue passed the corrosion test, if we look at them very closely, we can see, for example, this number 2 plug. You can see the scraping there. Maybe if I move it over to the black, you can see the metal scraping there. There was a little bit of difficulty extracting this one because it had started to swell right around there. And fortunately, the threads here were enough to act kind of like the extractor and just push it out and pull it out to the point where it wasn't, difficult for us. So we've got 2 that were kind of swelling. I'm sure these other ones, like this one here, this number 6 plug, we can see it also was just, it hadn't bulged, but you could see it was a super snug fit, again, because of the scraping that you got while you tried to remove the electrode from the bore. And again, like I said earlier, if anything is wrong with any one of the 8, all 8 have to go. These particular plugs has these 60Gs were replaced, I think about 115,000 miles ago. So mileage alone is not the sole indicator to replace them. It's something that you should check, I would say, about every 3 to 5 years just to inspect them and make sure they're in good shape along with the wiring. Anyway, I hope this helped you out. We tried to spend a lot of time covering a lot of things with wiring, testing harnesses, testing plugs, and also doing the extraction of the hardest ones here on the passenger side with the least amount of disassembly. If you got questions or comments, leave them below. If you do things a different way, I'd love to see it. If you found this video useful or it saved you some time or money, hit that like button and hit that thanks button. And as always, thanks for watching.